Hello and welcome to Symbolic Logic. Today I'm going to spend some time talking to you about strategies for working proofs. This week we'll continue to build on our skills that we have been developing for thinking about proofs, and today I'm going to be pulling material from a unit handout that you got with Unit 12. So you can find this handout on Moodle. And I'm going to be talking through some different strategies for working proofs and have some example proofs here to apply these strategies. Okay, so these are the strategies that are given in this unit handout. So what it says, first of all, is in order to find a solution for a proof, we need to begin by observing the premises and the conclusions, right? And importantly here, I think what we need to think about is what connectives are involved in the premises and the conclusions. Importantly, what is the main connective in each? And you can remind yourself of what the main connective is by just thinking, what would be the last column that I would compute if I were working out the truth value of these sentences, of this sentence on a truth table? The last column you would fill in on that truth table is your main connective, right? So if we look here at our first example, which is given underneath this premise one, or step one, strategy one, we can see that, the main connective for the premise on the right is the disjunction symbol. So this is a disjunctive sentence. And the main connective for the sentence on the right is the conditional symbol. So we would describe the sentence on the left as a disjunctive sentence and the sentence on the right as a conditional. Okay, so how would we go about showing that this argument is valid? Well, again, so we've identified those main connectives there now. And so what we want to do is think about elimination rules that you would be likely to use in moving away from the premises, right? So the premise is a disjunctive statement, so presumably we would use disjunction elimination to move away from that premise toward some other thing we wanted to derive. And then what introduction rules would you be likely to use in moving toward the conclusion, right? So our elimination rules are, as I've described before, move away rules. They help us move away from sentences that we have as premises or steps. And our introduction rules are move towards rules. They allow us to get to derive sentences involving those connectives that we actually want. So we have here P or Q, and so a kind of elimination rule that we might expect to come up in this proof would be disjunction elimination, right? We'd use disjunction elimination maybe to move away from this thing. So we wouldn't be surprised if that rule figures in our proof. This again is a connective or a conditional statement. So we would expect conditional introduction to figure in this proof as well. All right. And we know that our conditional introduction proof rule is a fairly complex one. And so we might just build this whole proof around that idea, around the idea of conditional introduction. So if we try that, when we set up the proof, we're going to, first of all, again, we always set up our Fitch bar first, and we're going to draw in our first premise here, which is P or Q. And now again, our goal is, it's not the case that Q, if it's not the case that Q, then P. So how are we going to get to that? Well, what we want to do is, again, think about what that goal is, and it's a conditional sentence, right? So presumably conditional introduction is going to be the primary rule of derivation that we use in reaching this conclusion. So how does our conditional introduction rule work? Well, what we do in conditional introduction is we say, suppose that we had the antecedent of this conditional. Would the consequent follow from it in this context? And so what we want to do in a conditional introduction proof is first suppose that the antecedent is true. So we're supposing that not Q, the antecedent of our desired conditional, is true. And now we want to try to show that P would follow from that thing. And so if we're doing a conditional introduction, we can make a little note of that when we make our assumption. This is for conditional introduction. And in general, as we'll talk about in a minute, we should always know where we're going to end up when we start a subproof. And in this case, it's pretty obvious that what we want is P, right? So P is the desired goal that this subproof is going to end with. Okay, and so as a matter of fact, we can get P quite quickly here. So at step 3, we can derive P straight away using disjunction elimination of 1 and 2. And so now we've shown that if not Q were true, then P would follow. And so at step 4, we can assert our conclusion. If not Q, then P. And so that is conditional introduction. And the way in which our conditional introduction rule works is we cite a subproof in its entirety, the subproof that got us from the antecedent of the conditional to its consequent. So conditional introduction, steps 2 through 3. Okay, and so that is our derivation. Now, a couple of things to note here. First of all, we did end up using both of these rules. As you can see, here's this rule and here's this rule. And another point is that our overall structure was supplied by the conclusion that we wanted to derive here. The conditional introduction rule gave us the structure of this proof. Okay, let's turn now to a second strategy for thinking about how to derive the conclusion of a premise. So the second strategy involves thinking about the problem informally. In this case, we are presented with the following premises. I'm just going to start setting up the Fitch bar here as we think through this. So we're presented with the following premises. So step 1 tells us we have A or not B. And step 2 is, or premise 2 is, it's not the case that either A or C. So it's saying neither A or C hold. Okay? And again, our goal here is to derive not B. So how are we going to get that? Well, again, this strategy tells us to think about the problem informally. So how would we explain the validity of this conclusion from these premises to someone who's very simple, who maybe doesn't even understand pretty basic inferences? They need the very simple inferences that our deductive system provides. When I'm thinking about a problem informally, I like to go ahead and construct a sentence key for that thing that'll give us some idea about what these things mean, a way to talk about them in a way that doesn't just require us saying A or not B over and over. So let's go ahead and plug in some values for these sentences. So let's say A stands for Moggy is a mammal. Let's say B stands for Moggy is a cat. So the reason I'm choosing these is that it makes our first sentence fairly intuitive. What our first sentence says now is either Moggy is a mammal or he's not a cat, and that seems accurate. And then let's suppose that C stands for well, we're going to deny this thing with, at the same time we deny Moggy is a mammal. So let's say it says Moggy is a bird. Okay, so what 2 now says is it's not the case that Moggy is a mammal or a bird. And now we want to derive that it's not the case that Moggy is a cat from this. Well, if it is true, and it is true, that either Moggy is a mammal or he's not a cat, then if we know that Moggy is neither a mammal nor a bird, then it will follow that he is not a cat either. Because if he's not either of those things, then he's not one of them. So how are we going to derive this? Well, I think one thing that stands out here, and just working through this informally again, is if Moggy is neither a mammal nor a bird, then it follows that he's not a mammal. And if he's not a mammal, then according to premise one, he can't be a cat either. So it would follow that he's not a cat. So what we want to try to do here is think, in effect, how are we going to get not A out of premise two, right? Because if he's not a mammal, then it follows that he's neither a mammal or a bird. So what we're going to do here is we're going to first suppose that A is true. Okay, so this is a supposition. And so if I were talking through this informally again, what I would say is, well, suppose that A is true. Well, then it would be true that, so if A were true, then it would be true that Moggy is a mammal or Moggy is a bird. If Moggy is a mammal, then Moggy is either a mammal or a bird. So that would follow, and that would follow from disjunction introduction, right, from 3. But now we would have a contradiction here, right? So what we have in effect is one of our premises says it's not the case that Moggy is either a mammal or a bird, and yet step 4 here says Moggy is a mammal or a bird. So we have a contradiction. The way we're going to show that contradiction is we're just going to reassert step 2 within this subproof, because our rule for negation introduction requires us to reiterate, requires both of the contradictory statements to be within the subproof. So again, this was for negation intro from 3 to 5. So now at step 6, we are in a position to assert the opposite of step 3. We've shown that assuming A led to a contradiction, so we can now assert not A. And what we cite for that is negation intro from 3 through 4. So we're going to have overlapping expanses within a subproof that show that contradictory things arose from that. So we now have not A. And now look, if it's not the case that Moggy is a mammal, then it follows from that he is not a cat according to step 1. And so the way we would assert that is by just saying it's not the case that B via disjunction elimination of 1 and 6. So I think thinking through these things informally can help us to see why the proof follows, why the conclusion follows. All right, so let's move ahead. So our third strategy says that we should devise a general strategy for solving the proof. So in general, when you're starting into a derivation, it's good to have a general strategy about how you're going to go. Now, that doesn't always mean that you're not going to get stuck at some point, but our next rule will come in at that point. And it says when you do get stuck, look back at what you have available to you and brainstorm possible rules that you might implement given that material. Right? So if you have a disjunctive available to you, you may use disjunction elimination to try and get somewhere. If you have a conjunctive statement, you may use conjunction elimination. So in general, when you get stuck, you want to think about the steps and premises that you have available to you, and what elimination rules can you use to work with those things. All right, I'm going to show both of these strategies at work in this next premise. So in this premise, we are provided with the following, this next proof. In this proof, we're provided with the following premises. So 1 says it is not the case that B. If it is not the case that B, then A. 2 says C. If C, then D or E. 3 says if D, then not C. 4 says if, it keeps happening. If B, then not E. And then our goal again is if C, then A. Okay, so again, we want to devise a general strategy here. And in general, I think if you're presented with a goal that is a conditional, a general strategy that it's good to adopt, at least initially, is conditional introduction, right? Conditional introduction, again, sets up a whole proof. So you know where you need to go with this thing. So, okay, so if we had C, could we get A out of these premises? Well, let's just think about the strategy here. So what we're going to do if we're doing a conditional introduction is we're going to suppose, and I'll just write it in, we can erase it later if this doesn't work out, but we're going to suppose C. And our aim is that C will get us to A. So could that happen? Well, let's think strategy for a minute, a general strategy here. So if we had C, then we could straight away, through premise 2, derive D or E. Now, if D or E were true, what would follow from that? Well, maybe nothing directly. I mean, we have a lot of conditionals in here, one of which does start with D, premise 3 does. But if we have D or E, then we don't have D by itself. So presumably at that point, we would need to assume something else to be able to work with D or E. And presumably that thing we would suppose, since we have D as the antecedent of a conditional at step 3, we would want to try to get D. So maybe what we would do is suppose it's not the case that E. That would, of course, let us get D. And then if we had D, we could derive not C, which would give us a contradiction, right? Because we're operating under the assumption of C within this proof. So then, if we had a contradiction, we would be able to derive E at that point. And what would happen then? We'll have to think about that. So let's give this a shot. So what we're going to do is we're going to try to go down this path, right? So again, at step 6, so our overall strategy is to derive A in some way from our assumption of C. So at step 6, we are going to derive the consequent of our conditional. If D, then E. And we get that via conditional introduction of 5 and 2. Okay, and I forgot to put in here that for this last assumption, C is assumed for conditional intro, and our conclusion, or what it's going to end in, ends in A. Okay, and now 7, we have, oops, I made a mistake. This should have been D or E. So at 7, what do we do? Well, again, what we're going to do is we're going to suppose that not E is the case. That was our general strategy that we set up. So we're going to suppose not E here. And again, this is also for a conditional, this is for a negation elimination. We're going to try to get E out of this thing. And I think that should be able to help us somehow. Because look, if we had not B, we would actually get A. And here, like, if we end up with E, then we can assume B, which will give us a contradiction because we'll derive not E. And then that will allow us to ultimately end up with not B, which will give us A, which is our desired goal. So this is actually going to involve 2 reductios, 2 negation proofs, and also our conditional proof. So we've got a good way to go here. So at this point, we've got not E. At step 8, we want to derive D from 6 and 7. That's conditional or disjunction elimination. And now with D, follows from that, that not C via conditional elimination of 3 and 8. And now, look, again here, we wanted to get, this was for a negation elimination. So we're trying to get a contradiction. I want some kind of contradiction within the subproof. And now look, we've got not C here, and we're still operating underneath this assumption of C. So we can just reassert that thing here. And now we've introduced a contradiction, which allows us to derive E, because assuming not E led to a contradiction. So not E must be bad. And if not E is bad, then E is what is true. And so we're going to assert E here via negation elimination, which is what we're aiming for. Right, remember, you can always keep track by looking back to what the note you made at the beginning of the assumption that you're trying to discharge at this point. So we're going to say negation elimination of 7 through 10. Oops, we need overlapping contradictory items. So 7 through 9 and 7 through 10. And then at step 12, we have E available to us. And now what do we do? What do we do? Well, I think this is a good point to remind ourselves that when we get stuck, we should look at what we have available to us. So what we have available to us right now is all of our premises, 1 through 4, assumption 5, D or E, which were given by 6, and also now E, which is available at 11. So how are we going to do this? Well, notice what we ultimately want down here is A. So somehow we're trying to get A. And I see that A appears in premise 1. So if I had not B, I could derive A straight away via conditional elimination. So how can I get not B? And of course, the way to get a negated statement is through negation introduction. And how that works is I would just assume B and show that it leads to some kind of contradiction, and then that would allow me to assert not B. So let's see, can we do that? Can we show a contradiction from not B? So I'm going to suppose here that not B is the case, and this is for negation elim of, and this will end in, the subproof will end in contradictory statements. So in fact, at step 13, we are going to be able to derive, we wanted to assume here, this isn't for negation introduction or negation elimination, it's for negation introduction. And so we're actually going to assume B here. So if B were true, then not E would follow from that via conditional elim of 4 and 12. And then if not E is true, well, we can reassert E from 11, and that gives us our desired contradiction. So now we can assert at 15, not B. 12 through 14. And then at 16, of course, if we have not B, then straight away we can get A via conditional elim of 1 and 15. So we've got A now. At step 17, at this point we have ended up with the desired consequent of our conditional. So at step 17, we can go ahead and assert our desired goal. If C, then A via conditional intro of 5 through 16. So we cite that whole proof for that conditional proof. Okay, so notice this gave us an overall strategy. It proved effective, but at some points we got a little hung up. And when we did that, we just looked back at what we had available to us and we thought through things and we were able to derive our conclusion in that way. Okay, another very crucial tool that we have available to us, one that was on display here, is something called indirect proof. So in the case of an indirect proof, what in effect you're doing is not really showing that the thing you're aiming for is the case, but rather showing that its opposite cannot be the case, right? So an indirect proof is one that relies upon reductio to derive your desired conclusion by showing that the opposite of what you want leads to contradiction. So let's see that in indirect proof at work in this premise. So in this proof. So what we're given here is at step one, we have it's not the case that A and not B. And our desired goal is A or B. Okay? So if we're going to show this through an indirect proof, what we actually want to do is to suppose the opposite of our goal, right? So we're going to suppose the opposite of this thing. And then we're going to show that that leads to a problem. So what is the opposite of this? Well, the opposite is just the negated or the non-negated version of the thing. So here we have A or B. So the opposite of A or B is not A or B. And now we want to attempt to show that this leads us to a contradiction. Well, at step three, how could we do that? Well, first of all, it seems like we could derive from this, right? If we had A, if we assumed A, we could get a contradiction and get not A. And if we assume B, we could similarly get a contradiction and get not B. Both of those would rely upon disjunction introduction. And so if we had those two things, not A and not B, then we could conjoin them, and that would give us a contradiction with this, okay? So I see a way to get to the contradiction that we want here. So let's take a stab at that. So what we're doing here, again, this is for negation elim from, and so what we're going to end up with is a contradiction of some kind. Okay, so we're going to start out here by supposing that we're going to suppose that A is the case. So we're going to suppose that A is the case. If A were true, then A or B, and so again, this is for negation intro, and so this will end in a contradiction too. So we're going to suppose, if we have A, we can assume A or B via disjunction intro from 3. At step 5 then, we will be able to assert, so we can reassert not A or B via reiteration of 2. And then what we've ended up with there is not A via negation intro 3 through 5. All right, so we got not A. Now we just need not B to make this strategy work. So what we're going to do is we're going to suppose B to be true. Again, this is for conditional intro. We know it's going to end in a contradiction. At step 8, we can again assert A or B via disjunction intro of 7. At step 9 then, we can assert not A or B via reiteration of 2. And then we are in a position at step 10 to assert not B. And if we have, and so the way we got not B was from a negation intro. Oh, I set it up wrong over here. It should have been 3 to 4 and 3 to 5. Sorry, cat interlude. I apologize for that. This is, well, I think his name now is Randy. He's a new cat we adopted. So if we have not B here, then we can assert at step 11, not A and not B. And so that will be via conjunction intro, which follows from 6 and 10. This guy was actually from negation intro from 7 through 8 and 7 through 9. And so now we've got a contradiction if we are able to assert that again. So we're going to reiterate, not both not A and not B. So that comes just from reiteration of 1. And so that led us to a contradiction, which gives us A or B, our desired goal via negation elimination of so as I work 2 through 11 and 2 through 12. Okay, so an indirect proof was very helpful to us there. Indirect proof, you just assume the opposite of what you want to show. Show that that thing leads to a contradiction, and that gives you the opposite. Okay, so I think another important thing to bear in mind is that you need to know, you need to be able to just remember the form of each of our rules. These are given in Appendix C in your textbook. So if you want to look back there, you can see the formal statement of all of our rules, and you should be able to recall these from memory. Another point that I'm going to illustrate with this next proof is not only that you need to remember the form of each of your rules, but also that you need to know how, in general, a subproof will end when you start it, right? I think I put this a little too finely on the handout that you need to know the specific thing it will end in. That may not be always the case in the case of a negation introduction or negation elimination. You may just know you need a contradiction, but not be sure of how to get to that contradiction. In conditional introduction, you will usually know precisely what you're going to end with, because it's just going to be the consequent of your conditional. So here we do have a conditional goal that we're aiming for. A conditional statement is our goal. And so we might just remind ourselves of how this rule works. And if we're really well practiced with our rules, then we should just be able to write that thing down. So we should know that our conditional rule is going to function by supposing that some premise phi is true, and then showing that that thing leads to some other premise psi. And then in that case, we know that we will be able to assert at step O, and then this is conditional introduction that we're thinking about, our conditional introduction rule. So we know then that we're able to cite at step O, discharging the assumption of phi then psi via M through N. Via conditional introduction M through N. And so this is how our general rule works. If we want to think about this, contextualize the particular subproof we're dealing with, what that rule would look like would be this. So we would assume not C. At some point, we're going to be able to derive A. And then that will allow us to assert not C, then A via conditional intro M through N. And so in effect, that's our general formation of our rule. And so how are we going to get that? How are we going to get there? Well, so we want to get not C, then A. So we're going to suppose that this case that we have not C available to us. And so that will be an assumption that we make. At step 5, we want to somehow get to A here. So I think what we're going to do in that case is we're going to, well, notice we have B or F available to us right away. So from not C, B or F follows via conjunction, or sorry, not from not C, but just from step 1. So via conjunction elimination of step 1, we can get B or F. Conjunction elimination of step 1 gives us B or F. When I have a conjunctive elimination rule, or when I have a conjunctive statement, I often like just to break it down because it's very easy to do that. If you have a conjunction given to you, you can tear it up into its various parts, and those can often prove more helpful to you. So now I think what we can do is, we'll notice we have this conditional statement. If we assume either one of the antecedents is false, well, if we assume that that F is false, not F, sorry, if we assume that B is false, not B, then we would be able to derive F. And if we had F, that would give us C from premise 3, which would be in contradiction with 4. So we could reject F, we could say not F. And then if we have not F, we can derive, or sorry, we start out by assuming not B here, and that gave us a contradiction. So then we can assert B, and if we get B, then we can derive A. So I think what we want to do at this point, seems pretty clear, is to suppose that not B is the case. And again, the form of our rule here is conditional intro, and we're going to end up with A. So that's knowing how our subproof is going to end. This one is for negation elim, and so we're going to end up with a contradiction. We always want to keep track of those items. Okay, so not B. So if we had not B, that would give us F via disjunction intro, a disjunction elimination, rather, of 5 and 6. And then if we have F, we can derive C from that thing via disjunction or conditional elim of 3 and 7. And now, lo and behold, with C, we have a contradiction. We can reiterate 4. That gives us a contradiction. So at step 10, we can derive B via conditional elim of 6 through 8 and 6 through 9. And now if we have B, we can get A via conditional elim of 2 and 10. And now we have completed our proof. So we've shown that if not C is the case, then A follows, and that is our conditional introduction from steps 4 through 11. Okay, so reminding ourselves the form of each of our rules, knowing how in general subproof end proved very helpful here, strategically speaking. And now the last point of strategy I want to point out bears on proofs without premises specifically. So a proof without premises can only ever begin with a rule that requires you not to cite a premise, right? A rule that doesn't require you to cite a premise. And we only have 3 of these available to us at this point. So these are those rules. So conditional introduction, negation introduction, negation elimination. There are subproof rules because our subproof rules start from assumptions, not premises. So if we have here this statement, A or not A and B, we know we're going to start with one of these rules. I think oftentimes you'll find it helpful to do an indirect proof in the case of a tautology, something that's true, logically true, can't possibly be false, because if you assume the opposite of that thing, you should be able to find a contradiction. So we're going to start out by assuming that the opposite of this is the case. So we're going to assume not A or not A and B is true. This is an assumption again. I didn't put that assumptive Fitch bar in, so let's do that. And now how are we going to get to the desired conclusion here? Well, notice if we had not A and B, that would allow us to get the whole inside of this thing, which would be in contradiction to our assumption at 1. We can use disjunction elimination, or disjunction introduction as a powerful rule to give us that disjunct. So I think what we're going to do next, and so this was for negational M, ends in contradiction. And what we're going to do next is we're going to assume not A and B. And this is for negation elim 2. So it's going to also end in contradiction. Then at step 3, well, if we have not A or B, then we can assert A or not A and B, or intro from 2. And now we can just reiterate our assumption. Then at step 5, we can assert the opposite of this, which will be A and B from conditional elim, or negation elim of 2 through 3 and 2 through 4. Then at step 6, we can just derive our A from this thing via conjunction elim of 5. At step 7, then, we can assert A or not A and B via disjunction intro of 6. And then at 8, we can assert, or we can reiterate again, A or not A and B, reiterate that from 1, which now allows us to assert a contradiction again. So we are now in a position to eliminate that condition, that negation elimination 1 through 7 and 1 through 8. So again, by starting with a rule that rested not upon a premise, but upon an assumption, again, a subproof rule, then we were able to derive this conclusion. Okay, I hope you find these strategies useful as you continue to work through proofs for this week and coming into the exam, which will appear later this week. Okay, I'll see you later. Bye.